everyone, and welcome to the third and the final video on POAC. In this particular video, we will conclude our concept of POAC by doing some very good examples and numericals. And once we are done with these numericals, then our concept of POAC will be truly clear, right? So without wasting any further time, let us go straight to the question. And as you can see in the question, it has been written that gravimetric determination of phosphorus has been done. NaH2PO4 by a series of reaction has been converted to Mg2P2O7. Now the question is, if 1.054 gram of Mg2P2O7 is formed, then what will be the amount of NaH2PO4 that has been taken? So basically we are asked about the weight of reactant and the weight of product has been given to us. And if you remember, gravimetric analysis is all about this weight analysis, right? So you can try this question by simply pausing the video, and when you are done with your attempt, you can simply resume, right? Okay, so I believe you may have tried it. Some people have done it, some people could not. No problem. I'm going to share the detailed solution of this question with you. And as we all know that here we do not know the details of the chemical equation, so it is impossible to balance this chemical equation. And if we cannot balance this chemical equation, then we will have to apply the same POAC concept. So let us apply POAC concept. Now the question is, on which atom we should apply POAC? The hint is already there in the question. It should be phosphorus. So let us start the solution and let us apply POAC on phosphorus atoms. And we know the statement. What is the statement? It is the number of moles of phosphorus atoms on the left hand side, here I will say extreme left hand side, is equal to number of moles of phosphorus atoms on the right hand side, that is extreme right. Now again we have to ask a very simple question to ourselves, that left hand side mein phosphorus kahan par hai? On the left hand side, phosphorus is there in NaH2PO4. And one molecule of NaH2PO4 contains one atom of phosphorus. So two molecules of NaH2PO4 will contain two atoms of phosphorus. So basically whatever is the number of molecules of NaH2PO4 will also be the number of moles of phosphorus atoms. So we can simply write number of moles of phosphorus atoms is equal to number of moles of NaH2PO4 is equal to. What about number of moles of phosphorus atoms in right hand side? Again, phosphorus is there in Mg2P2O7 in the right hand side, and one molecule of Mg2P2O7 has two atoms of phosphorus. So two molecules will have 4, 3 molecules will have 6. So whatever is the number of molecules of Mg2P2O7, twice that number will be the number of moles of phosphorus atoms. So we can write twice the number of moles of Mg2P2O7. Now what do we have to do next? We have to simply convert this number of moles into weight of NaH2PO4 divided by its molar weight, which has been given as 120, is equal to 2 into again weight of Mg2P2O7 divided by its molar weight, that is 222. Now as we can see, this weight of Mg2P2O7 has been given, so we can easily calculate the weight of NaH2PO4 from this formula, right? So let us move to the next question then. You may be observing that we are able to just do these questions in 1 or 2 lines. So that is what POAC does, है ना? The question looks very complicated, question बहुत difficult लग रहा है, but हम 1-2 line में ही इसको कर पा रहे हैं thanks to POAC. So the next question, as you can see on your screen, is 27.6 gram of K2CO3 was treated with a series of reagents, we do not know what, so as to convert all these carbon to K2ZN3 FeCN6. This is basically a complex, and this is FeCN6 twice, right? And we have to calculate the weight of the product. मतलब weight of reactant has been given and weight of product is being asked. Again यहाँ पर हमें केमिकल इक्वेशन ही नहीं पता, तो उसको हम बैलेंस कैसे करेंगे, राइट? सो बैलेंस नहीं करेंगे तो अगेन हमको कौन सा फॉर्मूला लगाना पड़ेगा, कौन सा कॉन्सेप्ट लगाना पड़ेगा? POAC. और क्वाइट क्लियरली हम लोग POAC किस पर लगाएंगे? डेफिनेटली POAC हम कार्बन एटम्स पे लगाएंगे. So again, applying POAC on carbon atoms, we can simply write that number of moles of carbon atoms on left hand side will be equal to number of moles of carbon atoms on the राइट हैंड साइड पे भी हम लगा सकते हैं, कोई प्रॉब्लम नहीं आने वाली है, ठीक है. अब फिर हमको देखना है कि लेफ्ट हैंड साइड पे कार्बन कहां पर है. वेयर एग्जैक्टली इज द कार्बन इज इन K2CO3 molecule, and one K2CO3 molecule will have how many atoms? 1 atoms. So whatever is the number of molecules of K2CO3 will be the number of atoms of carbon. So number of moles of carbon atoms is equal to, is nothing but number of moles of K2CO3. Again, on the right hand side, where do we see that carbon? We see that carbon in the complex, and each molecule of the complex we have how many carbon atoms? As you can see, 6 into 2, 12 atoms. So number of moles of carbon atoms will nothing but 12 into number of moles of this complex compound, moles of K2ZN3 FeCN6 twice, right? अगेन हमको क्या करना है? फाइनली इसको अपने फॉर्मूला में कन्वर्ट कर लेना है. एंड व्हाट इज द फॉर्मूला? weight of K2CO3 divided by its molar weight that has been given to us as 138 is equal to 12 into weight of the complex, लिख दे रहा हूं मैं, complex divided by its molar weight that is 698.3. अब अगर प्रोडक्ट हमारा कॉम्प्लेक्स है और कॉम्प्लेक्स का वेट निकालना है तो हम निकाल सकते हैं, प्रोवाइडेड की वेट ऑफ K2CO3 हैज बीन गिवन. Yes, it is there. It is 27.6. So very easily we can do this question also. Again, 2 lines. Only 2 lines we are using and we are doing this particular question. Okay, so let us move to the final question. That will be a very challenging question for all of you. That will be a good question in fact, and you will have to solve it. Take your time or whatever, but try to solve it. Okay, so let us move to the second question, and again we have the second question. A sample of 3 gram containing Na2CO3 and NaHCO3 loses 0.248 grams when heated to 300 degrees Celsius. The temperature at which NaHCO3 decomposes to Na2CO3, CO2 and H2O. मतलब सेम टेम्परेचर पे NaHCO3 डिकम्पोज होता है Na2CO3, CO2 और H2O में. What is the percentage of Na2CO3 in the given mixture? It's a very good question. Not only POAC but some other logics will also be applied over here. So if you want to solve this question, pause this video, take your time and then resume. Okay, so let us get into the solution of this question, and as you can see that there is a sample of 3 grams and it contains Na2CO3 as well as NaHCO3. So let us say I'm saying that weight of Na2CO3 is x grams, and what about weight of NaHCO3? It is, let us say, 3 minus x grams, क्योंकि टोटल कितना है 3. So अगर Na2CO3 x है तो ये कितना हो जाएगा 3 minus x. Now next it is saying that it loses some weight. How much? 0.248 when it is heated to 300 degrees Celsius. What will happen at 300 degrees Celsius? 300 degrees Celsius पे NaHCO3 will decompose. Okay, NaHCO3 will decompose and it will give you Na2CO3 plus H2O plus CO2. Let us say we are not going to balance this. Since we want to apply POC, let's not balance it. So we know that when NaHCO3 is heated, it gives us Na2CO3, H2O and CO2. Now keep this thing very clear in your mind that H2O and CO2 at this temperature will be volatile substances. So these will escape the reaction mixture. So whatever the loss we are seeing, that is 0.248 gram, that is because of these two. So these two's common weight or combined weight will be 0.248 grams. and whatever is left in the container, let us see, Na2CO3 newly formed and Na2CO3 the original amount, and both when combined, what will be the weight? Tell me. Weight of Na2CO3, I'm writing new. Why new? Because some of the Na2CO3 has been formed by NaHCO3, and weight of Na2CO3 old, what do you mean by old? That was already there in the mixture, that is equal to, just tell me, 3 ग्राम से कितना कम हो रहा है? 0.248 ग्राम. So this is 3 minus 0.248 gram. So this will be 2.752 grams. Now what is the weight of Na2CO3 old? मतलब मिक्सचर में पहले से कितना था? तो मैं बोलूंगा मिक्सचर में पहले से था x ग्राम, और कितना Na2CO3 न्यू फॉर्म हो रहा है वो देखने के लिए हमको इस पर्टिकुलर इक्वेशन में POAC अप्लाई करना पड़ेगा. कौन से पर्टिकुलर इक्वेशन में? जिसमें NaHCO3, Na2CO3, CO2 और H2O बन रहा है. ठीक है, तो चलिए अप्लाई कर देते हैं POC. ऑब्वियसली क्या कंजर्व कराएंगे? लेट अस कंजर्व सोडियम, राइट? सो अगेन सोडियम ऑन द लेफ्ट हैंड साइड, सोडियम atoms on left hand side will be equal to number of moles of sodium atoms on right hand side. कहाँ पे है लेफ्ट हैंड साइड में? NaHCO3 में. एक मॉलिक्यूल में कितना एटम है? एक एटम है. सो वट एवर इज द नंबर ऑफ एटम्स ऑफ सोडियम will be the number of moles of NaHCO3. So this can be written as number of moles of NaHCO3, and right hand side can be written as number of moles of Na2CO3 multiplied by 2. Why? अभी तक आपको पता चल गया है, बिकॉज एक Na2CO3 मॉलिक्यूल्स में 2 सोडियम एटम है, 2 में 4, 3 में 6. So whatever is the number of moles of Na2CO3 molecule, twice that number will be the number of sodium atoms of course, और वही हमको यहाँ कंजर्व कराना है. अब number of moles of NaHCO3 हमको कैसे मिलेगा भाई? number of moles of NaHCO3 हमको बहुत इजीली मिल जाएगा, क्योंकि हम लोगों ने देखा था कि it was 3 minus x ग्राम, इसका वेट था 3 minus x ग्राम, राइट? और इसका मोलर वेट कितना हो जाएगा? इसका मोलर वेट हो जाएगा 23, 24, 36, 36 and 48, that is going to be 84. So इसका 84 ग्राम हो गया. And what about the number of moles of Na2CO3? अब अगर Na2CO3 की हम लोग बात कर रहे हैं तो नंबर ऑफ मोल्स के लिए तो हमको वेट फाइंड करना ही है. वही वेट तो हम फाइंड करना चाह रहे हैं कि what weight of Na2CO3 has been formed, that is the new, basically this is new Na2CO3, divided by its molar weight, that is 23 into 2, 46, 46, 58, and 58 and 3 into 16, that is 48, gives us 106 grams multiplied by 2. तो यहाँ से हम देख सकते हैं that new Na2CO3, the newly formed Na2CO3 will be equal to 3 minus x divided by 2 into 84 multiplied by 106 grams. अब इसको हमें किस इक्वेशन में पुट कर देना है? यहाँ पे पुट कर देना है. 3 minus x divided by 2 into 84 multiplied by 106, एंड दोनों को कंबाइन करने पे कितना मिलना चाहिए? 2.752 grams. अब ये जो इक्वेशन नंबर 1 में लिख रहा हूं, अगर आप इसको सॉल्व कर देंगे तो आपको x मिल जाएगा, और अगर आपको x मिल गया तो टोटल वेट है 3 ग्राम, तो आप क्या कर सकते हैं? यस, परसेंटेज निकाल सकते हैं. सो दिस इज इट फॉर दिस पर्टिकुलर क्वेश्चन. This is it for this particular question. This is the complete solution of this particular question. Hope you enjoyed these videos on POAC, right? And तब तक के लिए we will come up with some new concepts, and तब तक के लिए let us say bye to you. So thank you for watching this.